Hi everyone, today I'll be walking you through my Physics 2 charged tape lab. The goal of this experiment is to explore how charged objects interact and to see Coulomb's law in action with something as simple as pieces of tape. The main equation we used is Coulomb's law, which is KQ1 Q2 over R squared. And we also used the electric field equation, which is KQ over R squared, R hat. And we also balance it with gravity, which is FG equals mg, or F sub g equals mg. This allows us to calculate the charge needed for two tapes to repel each other and reach equilibrium. Here you can see the pictures I took during the lab. In these shots, I'm basically holding just a strip of tape near another strip that's been charged. And by pulling the tape from the surface, both strips gain the same type of charge, so they repelled each other. You can basically just see how I'm carefully holding the tape so I can measure how far it displaces when it's repelled by the other. And yeah, as you can see, it's the tape on top has been pushed up compared to the first time. This just shows the real life effect of electric force, and yeah, just two very light objects moving apart simply because of their charge. On paper, I worked out the relationship between the electric force pushing the tapes apart and the gravitational force pulling them down. At equilibrium, Fe equals Fg times tan theta. Fe is the electric force of repulsion. G equals mg is the tape's weight, and theta is the angle the tape makes when it's displaced. From this, I derived the required charge on tape, which is Q equals root mgd squared over k. Where d is the displacement, this calculation shows that even a very small charge can balance out the tape's weight and create a visible separation. In the pictures, that's exactly what I was observing, the repulsion between the two charged tapes. Finally, this program defines two tapes as spheres and calculates the charge required for equilibrium. It computes the electric and gravitational force, shows the force arrows on tape 2, orange for electric, blue for gravity, and it plots electric field vectors. So that's the cyan colored one around tape 1. So we can visualize how the field extends in space. And to answer the final questions for this lab, for question 1, what if electrons had positive charge and protons had negative charge? If the charges of electrons and protons were reversed, the physics itself would not really change, because what matters is the interaction of opposite and like charges, not the actual, quote unquote sign we've assigned to them. In our world, we've simply chosen to call the electrons charge negative and the protons charge positive. If it were the other way around, the same forces and effects would still happen. So with the tape, you'd still see repulsion between charge plate pieces and attraction between oppositely charged pieces. Only the labels, quote, positive and negative would be flipped. And for the second question, why is it important to handle the charged tapes as little as possible? It's important not to touch the tapes too much because, your hands and also most objects in the room can easily transfer charge. The skin is slightly conductive, so when the tape touches your hands or other surfaces, it can lose or gain electrons. This causes the tape to quickly discharge, which reduces the repulsion or attraction you're trying to measure. In other words, the more the tape is handled, the more it loses charge, and the weaker the effect becomes. That's why the best results come when the tapes are handled minimally and only by their ends. Thank you.